like I said, we are looking at concavity today and points of inflection. There are two different types of concavity. Do anybody know the two different types of concavity? There is concave up and there is concave down. Okay, we're talking about concavity is either going to be concave up or it's going to be concave down. Okay, and the main parts we look at here is this right here is a certain type of concavity. Right in here starts another type. Oh, I'll put the I have another type here. I'm back to the other one here. And then there. So, there are two different types. The green is one type of concavity, and the blue is another type of concavity. There are two different types. There is concave up, and there is concave down. Those are your two types of concavity. Concave up, and concave down. Those are our two types. We just need to know which one's which here. So, which type of concavity do you think the green is?
Probably up.
The green is concave down. Okay, the green is concave down.
Kind of makes sense.
The blue is concave up. Okay, just think about it if you're holding it with your hand. If I'm doing it with my hand, which way am I pointing? Down, so it's concave down. If I'm holding it with my hand, which way am I pointing? Up, so it's concave up. Okay, so concave up is here, concave down is there. All right. Now, what we use to figure out concavity is the second derivative. Okay, the second derivative tells me concavity. If f prime of x, or f double prime of x is greater than 0, I am concave up. And if f double prime of x is less than 0, I am concave down. So what's another word we can use instead of less than 0? Negative, and instead of greater than 0, positive. So if my second derivative is positive, we are concave up. If my second derivative is negative, we are concave down. Now, we're going to use the first derivative today to figure out whether or not, or to figure out my concavity. Okay? So, let's relate the second derivative to the first derivative. Let's see how good you guys are. If my second derivative is positive, what does that tell me my first derivative is doing?
Increasing.
It is increasing. F prime of x is increasing. If my second derivative is negative, what does that mean my first derivative is? Decreasing. Okay, now what you've got to get used to is, if I'm talking about two different functions, one of them I have to be thinking about positives and negatives, and the other one I have to be thinking about increasing and decreasing. We never think about positives and negatives together. If I'm saying one of them's positive and negative, the other one has to be increasing and decreasing. Okay? So, since I'm talking about concave up being positive with the second derivative, that means I have to be thinking increasing with the first derivative. Second derivative is negative, means the first derivative is decreasing. Okay? That is concavity. Now, the other thing we want to talk about today is what's called a point of inflection. Point of inflection is the other thing we want to talk about today. A point of inflection is where we change concavity. Okay, we change concavity where I change from concave up to concave down. Okay, so there's two ways to tell whether or not I am changing concavity. If my second derivative is doing what? Changing sign. Or if my first derivative is what? Changing from increasing to decreasing, or decreasing to increasing. That's how we talk about points of inflection. Points of inflection has to happen where my second derivative changes signs or my first derivative changes from increasing to decreasing or decreasing to increasing. So that's what we want to do today is we want to look at the first derivative and determine concavity and determine points of inflection. That's our goal today. Okay? Alright, now back on that sheet you guys are working on. Oops. Alright, so first thing we want to do is identify concavity. Were you here yesterday?
Yeah.
It's the same notes. We want to talk about concavity. Am I concave up? Am I concave down? So, now remember, I'm looking at the first derivative. So since I'm looking at the first derivative, what do I want to be thinking about?
Increasing or decreasing.
Increasing or decreasing. That's going to tell me concavity. Okay? What do you think about my graph A here?
Nothing.
Is it increasing? Is it decreasing? So what does that mean?
No concavity.
No concavity. Very good. So there's no concavity on the first one. All right. What about B?
You want us to explain why there's no concavity, or?
Yes. Why is there no concavity? Somebody tell me why there's no concavity on A.
Because it never changes from.
You said
increasing-
another bad
Or
word.
because f prime never changes from increasing to decreasing.
No. That would be a justification for point of inflection. I'm talking about why is there no concavity?
Because f prime is always increasing.
Because f prime of x is not increasing or decreasing. F prime of x is constant. That's why.
Oh, A. I thought you meant B.
Oh, we're looking at A. So, no concavity on A because f prime of x is not increasing or decreasing. All right, back to B. What did we say our concavity was on B?
Up. Concave up.
Concave up because
It's always increasing.
you said a bad word again.
Sorry. F prime is always increasing.
F prime of x is increasing. That's why we're concave up. Is there a point of inflection? No. Somebody else besides Zach talk. Why is there not a point of inflection?
It doesn't change from increasing to
You said a bad word again.
f prime of x does not change from increasing to decreasing or decreasing to increasing.
Very good. Very good. All right, so let's look at C. All right, somebody talk to me about concavity on this one. What does my first derivative start out doing?
It's decreasing.
Starts out decreasing?
Or no,
Left to right? Starts out increasing, which means it's concave up, and then what does it do? It starts to be decreasing, which means it's concave down. So since I have a part that's concave up and a part that's concave down, what does that mean I also have?
Point of inflection.
I have a point of inflection. Alright, so now back to yesterday when we were doing relative maximums and relative minimums. How did we justify relative max?
You meant,
If the derivative changes sign, or
So we're talking about a relative max. Be specific. We're talking about a relative max.
if it changes from 5 to
Keep saying
if f prime x changes from 5 to 2.
Alright, there is only one way to justify relative max, and that is f prime of x does what? Changes from positive to negative. There's only one way to justify relative minimum, which is
going from negative to positive.
f prime of x changes from negative to positive. Now, when I'm doing points of inflection, there are two different ways I can justify a point of inflection. Okay? What do you think my two ways are to justify the point of inflection? What happens at a point of inflection?
Changes from increasing to decreasing.
Increasing, decreasing, or decreasing to increasing. Alright, there's one. F prime of x changes from increasing to decreasing, or decreasing to increasing. Okay, that is one way I can justify a point of inflection. What's my other way I can justify a point of inflection? The second derivative is what? Alright, so what's the shorter way to say that? Second derivative does what? Changes sign. Those are your two ways that you're allowed to justify a point of inflection. My first derivative changes from increasing to decreasing, or decreasing to increasing, or my second derivative changes signs. Those are the only two ways you're going to justify a point of inflection. How many ways are there to justify relative max or min? One. Keep that in mind. Relative max and min, I can only justify it one way. Point of inflection, I can justify two ways, so keep that in mind. Alright, so on C, there is a point of inflection. Where is it at? Zero. And what is my justification?
It's changing from decreasing.
You said another bad word.
Part X is changing from increasing to decreasing.
Very good. That's my justification. So there's a point of inflection at 0, x equals 0, because f prime of x changes from increasing to decreasing. All right, let's move on to D. D. Raise your hand, talk to me about D. Talk to me first about concavity, and then talk to me about point of inflection. Jairus?
Concave up starts out concave up and then goes to concave down
All right. And is there a point of inflection?
at x equals 1 because f prime of x changes from increasing to decreasing.
Very good. And if f prime of x is increasing, what does that mean my second derivative is?
Positive.
Positive. If f prime of x is decreasing, that means my second derivative is negative. Okay? Good. E. Ryan, E. Talk to me about concavity to begin with.
Okay. Concavity from -4 to 3, or concavity up.
Concave up to begin with.
-4 to 3. And then concavity down from -3 to 1. And then, yeah, and actually, when you continue, does it go back up? It's concave down all the way down to 1, right?
Yeah.
Negative
From
1.
here to there, I'm up. From here to there, I'm down.
And then concave up 1 goes.
And then I'm concave up. All right, so give me points of inflection.
Points of inflection. That's just at the point that changes, right?
Right.
Okay, so at x equals -3, there's a point of inflection because f prime of x is changing from increasing to decreasing, and then there is a point of inflection at x equals 1 because f prime of x is changing from decreasing to increasing.
Excellent. Now, what does this look like in the original function? What do we say we started out as? Concave what? So concave up is going to be like this. And then it turns into concave down, which is going to be like this. So we're making that transition right here. Now this one right here, what do we start out as? Concave down, and then we turned into concave up. So it's going to have that transition in it. Okay, so keep in mind what the transition is going to look like. All right. F. Garrett, talk to me about F.
It's concave up to from -4 up till -2, and it goes concave down from -2 to 1, and then it goes back to concave up.
Okay, points of inflection.
At once inflection at -2 and 1,
Okay, why is it at -2?
because f prime of x is changing from increasing to decreasing,
And at 1?
because f prime of x is changing from decreasing to increasing.
Very good. Nicely done. G. Jasmine, G. my concavity?
Having concavity of concave up.
Okay.
Then you have a point of inflection at 0
Why?
because every prime of x is changing from wait. Help, classmates.
You got it yourself. You figured it out. What's my function always doing?
Increasing.
It's always increasing. So can there be a point of inflection?
No.
Why not?
Because the
F prime of x.
F prime changes from increasing to decreasing or decreasing.
So F prime of x did not change from increasing, decreasing, or decreasing to increasing. So there was no point of inflection. Good. See, that's why you justify. Because she started out by saying there's a point of inflection. But then when she started to justify, what happened? You saw you were wrong. So that's what's good about justifying, is because you know something has to happen to justify it. So that was good. I'm glad that happened.
You're the truth.
H, Chris.
Concave up from the start until 1, and then concave down from then on.
All right. Point of inflection.
At 1
Because?
it changes.
Huh?
If I'll say if.
No.
It's an F.
Nope.
F apostrophe F prime of x changes from increase and decrease.
All right. Good. All right. Let's go to the front row. Melody, A. Concavity.
Concave down. And there's no point of inflection because it's always decreasing.
All right. You said it though.
F prime of x is always
You always
decreasing.
kill me.
B, Amelia.
Concave down from -2 to 2, and concave up from 2 to 5.
Okay. Is there a point of inflection?
No.
What'd you say what's my graph doing to begin with on the left? What's F prime of x doing? Decreasing. What's it doing on the right?
Increasing
So is there a point of inflection?
at 2,
Because?
because it goes from
Yeah.
decreasing to increasing. Because F prime of x goes from decreasing to increasing.
There you go.
From the start.
I'm gonna say F prime.
All right. C, April.
Concave down from -3 to 0, concave up from 0 to 3. Point of inflection at x equals 0 because f prime of x changes from decreasing to increasing.
Very good. And Garrett finishes up with D.
Concave down from -2 to 1. Hold on, it's confusing. And then, would it be concave down the whole way
Mm-hmm.
from -2 to 5? And then
-1 or 1 to 5. No, I want you to say concave down -2 to 1, concave down 1 to 5.
Okay. And
Point of
then
inflection.
Point of inflection. No point of inflection.
Because
F prime of x doesn't change sign.
It's
You
doesn't
can't say that
no
because F prime of x doesn't change from increasing to decreasing or decreasing to decreasing.
correct. That's what I want to hear. All right, now Garrett, talk to me about my second derivative. What is my second derivative doing right here?
Second derivative.
What is my second derivative right there?
Decreasing.
No.
It's negative.
Negative. What's my second derivative over here?
Negative.
Negative. Why?
Because it's because F prime of x is decreasing.
Good. All right, back on C. Back on C, Jasmine. What is my second derivative from -3 to 0?
From -3 to 0, it is negative
Why?
because f prime of x is decreasing.
All right, why? What is it from 0 to 2.5?
It is positive
Because?
f prime of x is increasing.
There we go. Chris, B, what does my second derivative start out doing?
It starts out negative
Because,
because f apostrophe x is decreasing.
and then what is it?
The opposite of what I just said. Oh.
Melody, A, what's my second derivative?
The second derivative is negative
Because,
f prime of x is always decreasing.
good. Amelia, what's my second derivative start out as on H?
Positive
Because,
f prime of x is increasing.
and then what is my second derivative?
Decrease. Negative.
Because,
F prime of x is decreasing.
very good. You guys got it down, concavity and points of inflection. Alright, go back through the homework problems.
I knew you were gonna do that.
I want you to identify concavity, I want you to identify points of inflection and justify.
You want us to do the inflection on one?
Yes,